Hi there. You've heard of the periodic table. You know, the really large, complicated table that contains the elements of everything. Now, I'm sure you've seen that this table can be a bit of a challenge to try and memorize. And very importantly, we can't memorize this table without actually understanding a little more about the background of this table. So what is it? Well, it is the table of elements. It's arranged according to atomic number, according to electron configuration, and other chemical properties. Where did it come from? Well, the original inventor was Dmitri Mendeleev. And why does it matter? Well, elements are the building blocks of matter. So what if I told you memorizing the first 20 elements could be as easy as telling time? And to add to it, not just the first 20 elements, but you can actually memorize a little bit of detail about these elements. Let's see how we go on this one. From periodic table to the first 20 elements, and then to the periodic clock. Okay, it is as simple as it sounds. You can turn the first 20 elements into a mnemonic device which you can efficiently learn to help you remember the first 20 elements. Focus Tech presents the periodic clock. Okay, so bear with me, we'll go through, we'll see if we can master this clock by the end of this video. Okay, so each element can be mapped to a position on the clock, which gives you a visual cue to be able to recall where that element's position is, and the number corresponds to the atomic number. So quite relevant and useful. So grab a pen, grab a piece of paper, and let's make some notes. Are you ready? Number 1, hydrogen. So hydrogen's symbol is H. Atomic number 1, it's considered a colorless gas. Falls under the group of non-metals, so group 1, and it makes up about 75% of our sun. Useful little fun fact about hydrogen. Next one is helium, number 2. Helium is a colorless gas, and it's on the opposite side of the table, far right, which makes it a noble gas. And of interest, helium is often used in floating balloons. I'm sure you've all seen those. Number 3, lithium. So lithium is an alkali metal. It comes across in nature as sort of a soft silver white metal, and it's very commonly used in cell phones. Those batteries are driven by Li-ion batteries. Number 4 is beryllium. So beryllium, less commonly used, mainly because it is a little tricky to utilize in its pure form. It's a little bit toxic. But that doesn't stop us from trying to use it. It's an alkali earth metal, soft silver white, and normally can be found in things like gears and cogs used in machines. Number 5, boron. So boron is a lustrous semi-metal. It's number 13 in the group arrangement. It's a metalloid. Okay, boron is commonly used in what they call borax, which is a laundry booster. Okay, so we've done the first 5. Let's see if we can memorize them a little bit better. So number 1 was H, 2 He, 3 Li, 4 Be, 5 boron. So that's a good start, but it's useful to add another keyword to try and improve your recall. So keyword for hydrogen could be the sun, the helium balloon, the lithium battery, beryllium gears, and for boron I would do soap. So pretty easy, but let's add another layer there. Let's do some images. So I do a little sun for hydrogen, some balloons for helium. You could do a little battery with some charge in it for lithium. You could do some gears for beryllium, and for boron you may want to do a soap dispenser. Okay, let's move on to the next one, carbon. So carbon's number 6 on the periodic clock and the periodic table. It's group number 14, which makes it a non-metal. So in nature, carbon has sort of a soft black appearance, but of particular interest, there are three natural substances which are really, really relevant when it comes to carbon. We have graphite, which is found in pencil lead, graphene, which is a really, really strong material. It's about 200 times stronger than steel, and we have diamond, which I'm sure we all know really well, nice and sparkly. Number 7, nitrogen. So nitrogen falls into group number 15. It is also a non-metal, and naturally it occurs as a colorless gas. And it's commonly used as ammonia, which is an ideal fertilizer. Number 8, oxygen. So oxygen is a non-metal, falls into group 16. It is a colorless gas. We know it really well. Breathing obviously is critical for normal survival, but of interest, you also find it in water, H2O, and it's actually produced during photosynthesis by plants as well. So a few keywords to keep us linked. Number 9, fluorine. So fluorine belongs to group 17. It's a halogen. It's actually got a bit of an irritating sensation if we get exposed to fluorine, but of particular interest, it's actually quite useful, and it's added to toothpaste to try and prevent tooth decay. It was also used originally as part of a larger molecule called chlorofluorocarbons, CFCs, and those actually contributed to depletion of the ozone layer, so that wasn't very good. Number 10, neon. So neon is a noble gas, falls into group 18. It is a colorless inert gas, and it's very commonly used in neon signs, particularly the red, high voltage, orange, red neon lights. The other colors, interestingly, are actually made from using different gases, not neon per se. Okay, let's fly through number 6 to 10. So 6 was C, 7N, 8O, 9F, 10, Ne. Now for that keyword, so we can do diamond for carbon, do fertilizer for nitrogen, could do H2O for oxygen, maybe CFCs for fluorine, and light for neon. Now adding in that image, you could do a little diamond for carbon. You could do some fertilizer, maybe just a little bag with a leaf on it. You could do some water for oxygen. We can do maybe toothpaste. I think CFCs is a bit tricky to draw. And for neon, you can do a light bulb. Okay, so far so good. Number 11, sodium. So sodium, really, really interesting metal, very, very important for normal life function. But of particular interest, it's an alkali metal, falls back into group 1. It's also a soft silver white metal, and in nature, we use this one a lot as a food seasoning in sodium chloride, or NaCl. Number 12, magnesium. So magnesium is quite interesting as well. It's part of the alkali earth metal group, or group number 2. It naturally occurs in sort of a light silver white metallic appearance. And of particular interest, they use this one in fireworks. So those little bright sparkles that you see in fireworks tend to be magnesium. Number 13, aluminium. So aluminium's atomic number is 13, as well as its group number. It's part of the post-transition metals. In terms of appearance, it has a rather non-lustrous appearance, but it is a silver white metal. And what's interesting with aluminium, it's very commonly used in the automotive industry for engine blocks in particular, and in the aviation industry for the structure of planes. And you may ask why? Well, it's light, strong, and corrosion resistant. So very good features for those applications. Number 14, we have silicon. So silicon, metalloid, group 14 as well. Appearance-wise, it's sort of a hard, dark grey, metallic, lustrous metal. Of interest, silicon is actually used by the electronics industry in computer chips. So little CPUs, or central processing units, are the main consumers of silicon. Phosphorus, number 15. So phosphorus is a non-metal. It is usually sort of a soft, colourless, waxy liquid. Waxy solid. And in terms of its main uses, so it's very, very common in red phosphorus, so safety matches. And we also have phosphorus in DNA that naturally has a sort of green glow to it. Next one, done 11 to 15. So quick recap, so 11 was Na, 12 Mg, 13 Al, 14 Si, 15 P for phosphorus. Going back through, adding our key word. So we had salt for sodium, we had fireworks for magnesium, we had aircraft for aluminium, we had a chip, so computer chip, and we had phosphorus tied to a match. And then to add another little figure or image, so add a little salt shaker, maybe some fireworks, we have an aircraft for aluminium, we have a computer chip for silicon, and a little match for your phosphorus. Number 16, sulfur. So sulfur is a non-metal, falls into group 16. Appearance-wise, sort of this pale, brittle yellow solid. If you live near a volcanic area, you would have probably seen sulfur as a yellow deposit, and it tends to have a rather distinctive smell as well. In terms of chemistry, very commonly used in sulfuric acid, a very corrosive liquid. Number 17, we have chlorine. So chlorine is part of group 17. It is a halogen. Naturally occurs as a green-yellow reactive gas. And of particular interest, we add chlorine to water, particularly drinking water and swimming pools, to help kill off bacteria. It's a natural disinfectant. Number 18, argon. So argon is part of group 18. It is a noble gas. So of particular interest there, it's colorless and rather inert. It doesn't like to react with other gases. And of particular interest, so we commonly use argon as a shielding gas during the process of welding. So fusing two metals together in the absence of air or oxygen in particular. Number 19, potassium. So potassium is a really important dietary component. It falls into group 1, which is the alkali metals. It naturally has a soft silver white and lustrous appearance. It's a very important dietary component that we obtain from bananas. And what does it do? Well, it maintains normal cell gradient potential, so it helps your cells to retain the right amount of fluid and to allow normal signaling to occur. So a really, really important component. Number 20, calcium. So calcium falls under group 2. It's alkali earth metal. In terms of appearance, it's a soft silver white lustrous metal, and of particular interest, it's also an important dietary component, and this one we find in abundance in milk. In terms of its function, it's actually really important, particularly in the nervous system, for cell communication through action potentials. Okay, recap, 16 to 20. So 16 S, 17 Cl, 18 Ar, 19 K, 20 Ca. Adding in our keyword, so we had acid for sulfur, we had pools for chlorine, you could do welding for argon, maybe a banana for potassium, and you could do some milk for calcium. Adding in our little image, so you could do a pool of acid for sulfur or sulfuric acid, you could do a person swimming for chlorine, so swimming pool. You could do some welding, looks like it's welding me in that particular image. You do some bananas for potassium, and maybe a glass of milk or a bottle of milk for calcium. Okay, pretty good. Now, in order to unlock all of this information that we just went through, you need to memorize position 20, position 5, position 10, and position 15. Those are critical. So we have calcium at 20, we have boron at 5, we have neon at 10, and we have phosphorus at 15. Really important to keep those in mind and anchor your memory. Okay. Now that we've gone through them, we need to start practicing visualizing this information. Okay, so keep in mind with each layer of information that we put in, we create more connections. More connections makes it very apparent to our mind that we are trying to learn this. So we need to really focus in on those added layers, and you can extend beyond what we've covered as well. So let's do some quick revision. Okay, working our way around. Hydrogen, we have the sun, helium balloon, lithium battery, and so forth. You work your way around, and then you can draw in your image. So again, following your way through, try and map out that image in your mind. So let's do a quick run through. So 1 hydrogen, 2 helium, 3 lithium, 4 boron, 4 beryllium, 5 boron, 6 carbon, 7 nitrogen, 8 oxygen, 9 fluorine, 10 neon, 11 sodium, 12 magnesium, 13 aluminium, 14 silicon, 15 phosphorus, 16 sulfur, 17 chlorine, 18 argon, 19 potassium, and 20 calcium. It's really important to work your way around, and if you do make an error, that's okay. The whole process is about trying to reinforce the correct order. So there will be points where you sort of get stuck, and you want to try and really zone in on those to improve your memory of it. So, some tips for effectively encoding or learning the first 20. So first one, recall. You must practice recall. It's a natural brain phenomenon. You need to enhance your memory by practicing recall, which is pretty much drawing out the clock over and over until you learn it in its entirety. So for the next tip, I would do revision. And the best way to do revision would be to pretty much try and recall this clock maybe once a day for 5 days. Okay, if you can do that successfully without error, you will have mastered that clock and you will know the first 20 elements without doubt. The next thing that I recommend is to expand on this. Okay, with each layer, you're going to add more connections, which means you're going to enhance your initial memory of the first 20. And you can do lots of things. You can do the group number. I think the group number is really important because that indicates the way that that element is going to interact in a reaction. It also gives you information about the number of electrons in the outer orbital, which is incredibly useful for chemical reactions. So keep that in mind. You want to see if you can broaden this and really make it your own memory device. So I guess we can say you've mastered the first 20 elements. But practice makes perfect. We need to do a run through. So very quickly. Number 1, hydrogen. 2, helium. And keep note of those keywords. So for hydrogen, sun, helium, balloon. Number 3, lithium. Number 4, beryllium. So for lithium, we had battery. For beryllium, we had gears. Number 5, soap. Going through, quickly adding in those images. Okay, make sure you follow through, add each of those layers, rehearse, and practice drawing them out. Next one, so we had carbon, diamond, we had fertilizer, or ammonia, we had water, our toothpaste or CFCs, we had our light bulb. So really try and zone in on these and add them to your visual memory. Next one, so we had salt shaker, fireworks, aircraft, computer chip, match. Running through again, we had that pool of acid, looks very corrosive. We had the swimming pool, not corrosive, thankfully. We had that person welding. We had the banana for our potassium, and that glass of milk, which always goes down well. Well done. Periodic clock mastered. So again, I will remind you, you want to revise this as many times as you can to really improve your memory of the first 3 elements. So hopefully you've enjoyed the content. I will say consider liking and sharing the video. If you have a topic request, feel free to leave a comment. If you want a challenge, I recommend going to my website, focustech.co.nz, where you'll find a word find, a crossword, and a jigsaw puzzle on today's topic, periodic clock. If you find yourself feeling very engaged with that, by all means enjoy those. They should help you to reinforce your memories because they're based on the first 20 elements. And I'll leave you with a quote. I like my Albert Einstein quotes, so today I'll leave you with: logic will get you from A to B, imagination will take you everywhere. Have a good day. See you in the next video.